Alright folks, welcome to 90.9 the quadratic for your Algebra 2 Chapter 3 Part A test review video. This test is going to be on Tuesday, October 25th. Alright, test is going to have about 18 questions. Could be 18 or 16 questions as you see here. Today we're brought to you by Tazo Zen Tea, Starbucks Coffee, Caldi Coffee, Pizza Man in Litchfield, and Coffee Espresso. Okay guys, on 1 through 12 here, it's all about figuring out, should I use substitution, should I use elimination. Guys, on number 1, look at the y's that match up perfectly, so you definitely want to use elimination. You have a negative 3y and a positive 3y. Those are opposite signs. Opposite signs mean you need to add. Add 2x and 4x. Together you're going to get 6x. If you add, the y's are going to cancel. 9 plus 9 is 18. X is 3. Plug this in for x in either the first or the second equation. I think the second equation is better. You got a positive y. 4 times x, 4 times 3 plus 3y is 9. You're going to get 3y is negative 3. Y is a negative 1. Guys, you want to use substitution for number 2 here. Y is equal to 5x minus 2. Plug that in for y right here. It's going to be x plus 2 times 5x minus 2 is 7. Use distribution. You get 10x minus 4. 11x minus 4 is 7. Solve, you get x is 1. Plug it in, Glade style. Nothing kills the smell of underclassmen quite like a Glade plug-in or a Glade spray. Mr. Yacht currently has the apple cinnamon. Smells heavenly. Plug 1 in for x right here. You're going to get y is 3. Alright, moving on here. Number 3, folks. You decide what you want to eliminate. You could eliminate the x's by multiplying this by 4. You can eliminate the y's like we'll do here by multiplying the top equation by 3. If I triple the top equation is now... Oh, made a boo-boo. This is not good. Uh-oh. Alright, so folks, unfortunately, if I write here, if I write, it will not pick it up. So what you should have done, if you triple the top equation, you're going to get negative 3x here. So when you add them together, you're actually going to get 1x equals 3. 1x equals 3. So x is 3. And if you plug that in right here, you should get y is, well, no, I don't think that's going to work. Let's see, 1 and, it's always good here when we make a boo-boo to figure out how we fix it. Negative 3x plus 3y equals 6. Add them together. You're going to get, again, 1x equals 3. This should be a 1x equals 3, so x clearly has to be 3. If x is 3, y is 5. Don't know why I got confused there. It should be 3 comma 5. This one should be 3 comma 5, not 1 comma 3. My bad. Alright. Guys, for number 4 here, you're going to multiply this top equation by 3. It doesn't matter what you're trying to eliminate. If you're trying to eliminate the x's or the y's, this is that same first equation just tripled. If you subtract, guys, you're going to subtract to get rid of either the x's or the y's. You're going to get 0 is equal to 22. That's a false statement. A false statement is no solution. Anytime the variables are eliminated, you're going to be left with a statement. If it's false, it's no solution. If it's true, it's all real numbers. Guys, on this one, maybe we want to eliminate the y, so you're going to multiply this by 4. You're going to get 32x plus 4y is 108. The 4 y's match up, same sign, you're going to use subtraction. Be careful here when you do 32 minus a negative 3. That's really 32 plus 3, 35. 35x is equal to 105. X is 3. Plug it in to the top equation. 8 times 3 is 24. Subtract 24 from 27. Y is also 3. Here, if I just double negative 6, I'm going to get a negative 12, and it'll be the opposite of 12. So I'll have 2x minus 12y equals 88. Everything is doubled. You're going to add these two equations together. You're going to get 11x is 88. X is 8. So you're going to plug that 8 in for x anywhere you want, maybe right here. 72 plus 12y is 0. 12y is negative 72. Y is a negative 6. Alright guys, on number 7 I had you change 8x to 9x. Alright, so we don't get a decimal. Maybe triple this equation right here, so that the y's are now opposites. Add them together, you're going to get 27x is equal to negative 27. X is a negative 1. Plug it in maybe to this bottom equation here. You're going to get y is a negative 15. Guys, on 8, the x's match up perfectly. So same sign, negative 4, negative 4. Use subtraction. Subtract. 5 minus a negative 2 gives you 7y. Negative 17 minus 18 gives you negative 35. Y is a negative 5. Plug negative 5 in for y right there. You're going to get negative 4x plus 10. This will be plus 10 is equal to 18. Subtract 8 from both sides. X is negative 2. On 9, if they're both equal to y, they're both equal to each other. So sets negative 2x plus 8 equal to 3x minus 7. You're going to solve. You're going to get x is 3. Plug it in right here. Y is 2. Here, it doesn't matter what you're trying to eliminate. You want to double the second equation, the bottom equation. If you do that, everything's opposite. So if you add the x's, add the y's, you get 0. Negative 26 plus 26 is 0. 0 equals 0 is a true statement. So this is all real numbers or infinite solutions. Clear-cut substitution on number 11. Substitute x plus 1 in for y. You're going to get 4x plus 3 times. This is y. X plus 1 equals 10. Use distribution. Combine the x's, move the 3 over, divide, x is 1. Plug 1 in for x right there, y is 2. Guys, 12 is the one where you're going to have to multiply both equations by a number. Maybe I want to get rid of the y's, multiply this by 3, that by 5. If I want to get rid of the x's, I can multiply this equation by 9, this one by 4. Anyway, I get opposites y's here, so I'm going to add. Opposite signs mean I add. You get 33x equals negative 198. X is a negative 6. Plug that into the bottom equation here maybe. You're going to get negative 54 plus 3y is negative 48. Add 54 to both sides. 3y is 6. Y is 2. Alright, so that should contain about 70%, or about 70 to 72 points on the test. The next parts, 13 and 14, this page is probably going to be 14 to 16 points on the test. What you want to do here, folks, is figure out what variable is begging to be eliminated. We're going to say bye-bye x. We got opposites. We got negative x, negative x. This is perfect. If I put 1 and 2 together, I'm going to add them together because I got a positive x and a negative x. I have opposite signs of what I'm trying to eliminate. Add everything up, I get y minus 7 is equal to 5. If I put 1 and 3 together, something sweet happens. Not only do the x's eliminate, so do the y's. I get negative 5z is equal to 15. Z is a negative 3. So I'm going to take that negative 3 for z and plug it in right here, right here. Y minus a negative 3 is 5. That gives you y plus 3 is 5. Y is 2. So maybe use equation 1. Plug 2 in for y, negative 3 in for z right there. Down here at the bottom, solve for x, you get 0. 0 for x, 2 for y, negative 3 for z. What's nice about 14 is you have no z's already in that second equation. So put 1 and 2 together and say bye-bye z. You can subtract because you have 1z and 1z. How do I make 1 and 1 0? I have to use subtraction. Subtract the third equation from the first. 2x minus 1x is x. 3 minus a negative 2 is like 3 plus 2, 5y, and that equals negative 9. Put them together right here. Maybe I want to get rid of the x's, so I multiply everything in the second equation by 3. Then I have 3x and 3x, same sign. I use subtraction. I'm going to have 1 minus 15, negative 14y equals 28, so y is a negative 2. Fantastic. Take that negative 2 and maybe plug it in right here. 3x plus a negative 2 is 1, or 3x minus 2 is 1. You're going to get x is 1. Then use equation 1 as I had here. Plug it in. 2 times x plus 3 times y plus z is 0. Dot, dot, dot. You get z equals 4. Alright, the last page is a little tougher to see what we did here since, there's a lot of shading going on. So the first one, guys, number 1, we're going to plot that first. It gets a solid line because you grab less than or equal to. So I'm going to plot 5 on my y-axis. I'm going to go down 2 over 1, down 2 over 1. Guys, plug 0, 0 in. If I plug 0 in for y, 0 in for x, I get the statement 0 is less than or equal to 5. That's a true statement. 0, 0 is below the line, so everything below the line is true. That's why I shade everything below the line on this first one. And the second one has a y-intercept of negative 6, a slope of negative 1/4. I go down 1 over 4. It's a dotted line because I have no equality. And if I said y is bigger than that line, it makes sense that I would shade above. Again, I plug 0 in for y, 0 in for x. I get the statement 0 is greater than negative 6. That's a true statement. So 0, 0, which is above the line, is true. So I shade everything above the line. Where my arrows come together, that'd be this region. That is my region of feasible solutions. That's where I shade really heavily. Next one, first equation, y-intercept of 4 right here, go down 3 over 1. It is a solid line. This is it. If I plug 0 in for x, 0 in for y, I get the statement 0 is less than or equal to 4. That is true. Where 0, 0? 0, 0 is below that line. That's why I shade below the line. Next one, y is greater than or equal to 2x minus 1. It's a solid line because of equality. Negative 1 is the y-intercept. I go up 2 over 1 for the slope. If I have y is greater than that line, greater than or equal to, it makes sense I would shade above. But I'm going to test 0, 0. 0 in for y, 0 in for x. You get 0 is greater than or equal to negative 1. That's a true statement. 0, 0 is just above the line. So everything above the line is also true. Where my arrows came together here on the left side is my region of solutions. That's what gets the dark, heavy shade. Guys, on 17 and 18, this is where I want to figure out where they intersect. Where they intersect is my answer. So right here, I have a y-intercept of 3. I go down 1 over 1. Go down 1 over 1 a few times. You can also go backwards. The opposite of going down 1, 1 to the right would be going up 1, 1 to the left. This is my first equation, my first line. First equation. Negative 6, the y-intercept here. I need to go up 2 over 1, up 2 over 1, up 2 over 1. So ding, 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 they intersect at 3, 0. Guys, right here, I have a y-intercept of 1. I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I can also go down 2, 1 to the left, down 2, 1 to the left, down 2, 1 to the left. Alright, my next equation has a y-intercept of negative 8. There's an issue. I can't go down 5 over 2. I'm running out of space. So I'm going to go backwards. I'm going to, instead of going down 5, 2 to the right, I'm going to go up 5 to the left. And ding, 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 they intersect there at negative 2, negative 3. Alright, folks, this is your test review. Your test is Tuesday. This is 90.9, the quadratic, signing out.